to the lecture of DSP. What are linear systems? As we have already discussed, linear systems are those systems which follow superposition theorem. Now, what is superposition theorem? It is a combination of two properties. One is additivity and second is homogeneity. Additivity: when we add two input signal and the output is the sum of individual outputs, while homogeneity is when we multiply input signal with a constant and that constant is also multiple at output. These two properties make superposition theorem. But for linear system there are some other properties, just like time invariance. When we apply shifting in input signal and that shift is also produced at output signal, then system is time invariant, means it does not depend on time. Are these properties enough? No, there are some other properties. First is sinusoidal fidelity and second is static response. Sinusoidal fidelity: when we apply sinusoidal signal to a system and output of the system is also sinusoidal with no phase shift, then this is called sinusoidal fidelity. Now, what is static response? Output is input multiplied by a constant, means output is same and only a constant is multiplied by it. Now we consider some examples of linear system. First example is Ohm law. This law is only valid for pure conductors and it is not valid for tube lights, bulbs, etc. Now if I consider a voltage at x-axis and current at y-axis, then as voltage increase, current increase and the resistance remains same. Means if voltage increased by 1, current is also increased by 1. If voltage increased by 2, current is also increased by 2. So a straight line is obtained. Now talk about Hooke's law. Hooke's law: F is equal to K of x. F over x is equal to K. Now what force we apply, change in displacement takes place, which is always a constant quantity. Special property of linearity is commutative property. If you have many inputs and output, then output will be linear if it is composed of linear subsystem. Means if there are many systems and all are linear, then their combination is also a linear system. Examples of linear system: wave propagation. Wave is basically a disturbance, it is a linear system. Second is electrical circuits. Electrical circuit include conductor, inductor, etc. Electronic circuits, it include amplifier, transistors. Mechanical motion like dampers, and followed by Hooke's law. Unity system. Now talk about unity system. When we give input to a signal and it gives same output, means there is no change while we put the signal into system or not put the signal into system, there is no change, then it is called unity system. Next, null system. What is null system? Whatever are applied at input, the response of the system is 0, means 0 signal is obtained. X of n is applied at system, then y of n is equal to 0. Now convolution. Convolution is also linear. Convolution is a sum of shifted scale versions of input. Recursion. A recursion: instead of input there is previous version of output, means it always depends on the previous version. Now consider some examples of non-linear system, like power is equal to I square R. This shows us that it is non-linear. How it shows us? Because every formula with a power greater than 1 shows that the system is non-linear. Linear systems have only the power 1 at the maximum. Consider hysteresis law. This graph clearly shows you that the system is non-linear as x-axis and y-axis does not varies directly. Saturation is also an example of non-linear system. Threshold value threshold value इसकी example जैसे silicon diode will allow the current to pass through it after a certain time. 0.7 voltage value, threshold value, so not linear at this point. Next is multiplication of two signals, because we don't know what result we obtain after multiplication of two signals.